All right, section 22.2. So notice we're done with module 20. Module 21, we're already into section 22. And this is about isosceles and equilateral triangles. We're going to get into defining those triangles. And then we're going to start looking at some practice problems and how do we solve different sorts of problems that we're going to see that involve isosceles and equilateral triangles. So get these definitions down here. 1, 2, 3 definitions. Isosceles, equilateral, and equiangular. And just know that this is always going to be the case. If something is equilateral, it is also equiangular. So that's a package deal. Those two come together. Okay, and we're going to see that in one of our triangles later on. So pause the video, get this written down, and then we're going to do a warm-up. Alright, so for the warm-up, we're going to be looking at some triangles, and I'm going to be asking you to find the missing angle or the variable. Okay. 60, 90, 20, 106, Y, Z, 10, 14. Okay, go ahead and find these missing variables, X, Y, and Z. You should remember that a triangle adds up to 180 degrees. Okay, so the three angles in a triangle add up to 180. Alright, do these on the left-hand side. Alright, if you're back with me, you have answers for X, Y, and Z. So I'm going to erase this now, and we are going to get started with some newer material, unless you've seen it before. So if we have a triangle, we're going to talk about the relationship between the sides and the angles of this particular triangle and any triangle that we're going to see. Okay, so relationship between the sides and the angles. Okay, so I'm going to label these vertices A, B, and C. If it helps you to use colors, I highly suggest you use colors for this part. If not, that's fine. Okay, and this angle right here actually corresponds to the side that is opposite of it. So the only side that it is not touching. So that side right there. It corresponds or relates to that side. Okay, for A, this angle, it corresponds or relates to the side that is opposite of it or is not touching. So this side right here. And the same with B. Angle B corresponds with this side, the side that is across from it or opposite of it, that it is not touching. Now what I mean when I say correspond is that if A is the smallest angle, this is the smallest side. If B is the biggest angle, this is the biggest size. So the size of the angle corresponds with the side. Okay, so for instance, if I were to say that A was 50 degrees, B was 60 degrees, and you should know that C would have to be 70 degrees. Okay, these are the angles, right? The angle measure. Measure of angle C. Measure of angle B. And measure of angle A. So if that is true, and I'm asking which side is the longest, the longest side is going to correspond to the largest angle. So this would correspond with angle C, which when we look at our diagram means that it's going to be opposite of C, which means that it is this side right here, which is interestingly enough side AB. So notice that even though it corresponds with angle C, right, noticing the letter C, the side does not use that letter. Okay? So using this again, this same measure of angle A, B, and C, let's order sides least to greatest. So to help me, I'm going to go ahead and label in my triangle. So I'm going to go ahead and say that A is, let me erase these little lines, still have my colors though. So A is 50, B is 60, and C is 70. Which tells me that my smallest side is going to be across from the A. So this is going to be my smallest side. It's across from my A, smallest angle. My medium side, or middle side, is going to be across from my 60. That's my middle side. And then my biggest side is over here across from my 70. So if I were to order them least to greatest, I'm going to say my smallest side is CB, my medium side is AC, and my biggest side is AB. Okay? Alright, so I'm going to give you some practice problems, so try to soak this in. Okay, so if I give you a triangle, and I'm going to tell you, I'm going to call it D, F, G, say 30 degrees, 75 degrees, 75 degrees. I'm not going to do that to you guys. 78, 72. Okay, so go ahead and list sides least to greatest. Go ahead and do this on the left-hand side. Pause the video and get this done. Okay, assuming that you already have this complete. You're looking for the smallest side first. So the smallest side is going to be across from that 30-degree angle, which is this side right here. So my first side should say DF or FD. My middle is my 72 degrees. So if I look across from it, I'm at this line right here, which is DG. And then my biggest is FG. That's exactly what my list should look like. These letters could be switched, the order, that's fine. Okay, so now I'm going to give you 3 to do completely on your own. And then we'll get into actually looking at isosceles and equilateral triangles. A, B, C, D, H, J, 21, 38, 121. So you're doing these on the left-hand side. I'll give you the middle one. Alright, go ahead and do these three on the left-hand side. When you're done with those, you can come back to this video. Alright, you should be done with all three of these on the left-hand side. Now we're moving on to actually looking at equilateral versus isosceles. So there's some components that we're going to have to just know and memorize about these. For me, it's easy because I get to look at the words and figure out what do the words tell me in them, especially with equilateral, not as much with isosceles. So equilateral versus isosceles. Alright, equilateral triangles. What are they? So a triangle that has three of the exact same angles. So if you think about that, we need three angles that are the same that add up to 180. Right? For an equilateral triangle. They're all three the same, that's what I told you, but we know that they equal 180. So the only option is 60, 60, 60. Which means that in an equilateral triangle, every single time it is 60 degrees, 60 degrees, and 60 degrees. Every time for the angles. Also, all three sides are the same. So, 3 equal sides, 3 equal angles, 60 degrees each. Okay, that's equilateral. Pretty simple, I think. Equa, to me, tells me equal. So everything is equal. All the angles are equal, all the sides are equal. Isosceles triangles. Alright, so here's an isosceles triangle. At least two of the sides are the same. So those two sides are the same size. So at least two equal sides. And what that means is that if we think about the corresponding angles, right, if we think about this side corresponds to that angle, right? If you didn't see what I just did, what I said was this side right here corresponds to this angle. Okay, so, and this side corresponds to this angle. And since the sides are the same size, the angles are the exact same size. So this isosceles triangle actually has at least two equal sides, which means that it has two equal angles. Okay, that's what an isosceles triangle is. So let's look at a couple examples, see if we can figure out what are they. Are they equilateral or are they isosceles? So we're just gonna, we'll do 3, and then I'll give you about 4 to do on your own. So if I'm just gonna let you contemplate on them, we're deciding what are they, equilateral or isosceles. Alright, here we go. First one, number 1. We have two angles right now that we know. Both of them are 60 degrees. So we have 60 degrees and 60 degrees. We should be able to find this third angle, because 3 angles in a triangle always add up to 180. So if we got 60 and 60, we know that this one right here must be 60 as well. And what does that mean when we have 3 equal angles? It means that it is equilateral. Since all the angles are equal, we also know all the sides are equal, because it corresponds to the opposite side. Okay, number 2. Number 2 gives us all 3 side lengths. It's got 6 centimeters, 6 centimeters, 5 centimeters. For me, it helps to draw in the dashes, so I'm going to say, okay, well, this side is congruent to this side. So it's not isosceles, or it's, I'm sorry, I misspoke. It is not equilateral, because if it was equilateral, it'd be 6, 6, 6, or 5, 5, 5. Everything would be equal, so it's not equilateral. So if we think about our options, okay, it's not equilateral. And we still think about isosceles. Does it have at least two sides that are congruent? Yeah, right there. And also what that means, what we should immediately be able to draw in, is that this side, or that angle, and that angle are congruent, or the exact same size. This is an isosceles triangle. Okay, for this triangle right here, we've got two 40-degree angles. That's enough. Well, so it's obviously not equilateral. If it was equilateral, it would be 60 and 60. Okay, so maybe isosceles. Let's try it out. Two angles that are the same. What that means is that this side and this side are the same. Now we have at least two sides that are the same size, which makes it isosceles. Okay, I'm going to give you 4 to do on your own, and we still have a little bit more to do with solving some actual algebraic equations for these triangles. Okay, here's 4 that you're doing on your own. You are telling me equilateral, isosceles, or neither. Okay. Alright, try these out. Tell me equilateral, isosceles, or neither. On the left-hand side, please. Okay, if you're back with me, you've already done these, so I'm going to erase them. And we're going to do our last couple problems, and then we will be done with section 22.2. Alright, here we go. We have an equilateral triangle, equilateral, and I'm given two side lengths. 6x minus 5 and 4x plus 7. Okay, two side lengths. It's an equilateral triangle. You have to hone in on the fact that it's equilateral, which means that all of the sides are the exact same length. All of the angles are the exact same size at 60 degrees each. So these two sides need to equal each other because they are the exact same. So when we think about that, we have 6x minus 5 equals 4x plus 7. And when we solve this out, I'm going to move all of my variables to the left, which is what works for me. And I'm going to move my numbers to my right, that's what works for me. So I'm going to add 5 to both sides, moving my number to my right. And I get 6x equals 4x plus 12. And then I'm going to subtract 4x, moving my variables to my left. And I get 2x equals 12, divided by 2. I get x equals 6. Okay? That is the variable. If I am asked, what is the side length? So if they ask me, what is the length of the sides? It is not, please, for the love of goodness, do not put 6. It's not 6. You need to take this 6 and plug it back into the equation. So it's 4 x plus 7, but I'm plugging in 6 for x. So I get 24 plus 7, which gives me 31. So the length of my side is 31, not 6. Okay? Alright, give you guys one similar. Actually, oh wait, I'm going to do one more. Here, this is what I'm given, and I've got x degrees and 3x degrees. And it's asking me to find x. And there is absolutely a way to find x here. So the first thing I'm going to determine is that this is an isosceles triangle. And the reason I know that is because two of the sides are congruent. So it is isosceles. This side corresponds to this angle. This side corresponds to this angle. What does that mean for me? Since those two sides are congruent, these two angles need to be congruent as well. Since this is x degrees, this is also x degrees. Now we also know that all three of these need to add up to 180. So if I set up an equation, 3x plus x equals 180, because we know a triangle needs to add up to 180, we get 3x plus 1x plus 1x, 5x equals 180. When I divide by 5, I get x equals 72, I believe. 70 times 5? No, that's definitely wrong. It's 36. 36, yep. 151, yep, good. Okay, so x is 36. If I were to ask for the measure of the angles, you would need to plug that 36 in. So this one would be 36. This one would be 36. This one is not 36. You have to plug that 36 in and solve for 3 times 36. And when I do that, 108, right, because 90 to 16, I get 108. And if I were to add these three up together, I should get my 180 again. Alright, awesome. So we've done these two. I'm going to give you 2 examples for you to do on the left-hand side, and then you will be done with this, and you will be able to work on homework if you have any time left. It's on your left-hand side. Okay, cool. So go ahead and find the length of the side for this one, and then we'll have a number 2. Alright, once you're done with these two, so do these on your left-hand side. And then once you're done with that, there is some homework that I'm going to write up here. Your homework is page 1104. To 1105. Number 4 through 9. Alright, there's your homework. So you are done with 22.2.